and welcome to my Java programming tutorial. In this video we will do recursive tracing. This question is from UW Seattle where they trace recursion, code is provided and values are provided. You have to pass those values and trace the output. So before jumping on to recursion programming, this is the best way to understand how recursion works. We will do like a couple of different example on recursive tracing, and all the coding will be different, like all the recursive calls will be different evaluated. We will see how. So let's get started. You will see a question in front of you. So this is the question. You can write it down, take a of this question because I will be switching the camera over the board. So that's the question I have written over here. I have a small board, so it's kind of messy over here. I will explain you. You can compare step by step with the document in front of you. Okay, so let's get started. So the first value we have is mystery 0. So when your n is 0. So as you can see, we have a static method. Public static int is the return type, the value we are returning. We have mystery is the method name, and then int n. So over here your n is 0. The first value you have passed. So let me write it down. Your n is 0. Now you have, these are two kind of base case, and then at the end you have the recursive case in your else. So if n is less than 0, is 0 is less than 0? No, we will move on to else if. Is n equals to 0? It says, and yes, your n is equals to 0. Value returned will be 0. So the first mystery call, your answer is 0. Let's take a look at the next mystery call, what we have. As we are moving forward in these mystery questions, it will get harder, as you can see by the numbers. Next mystery call we have is n equals to 5. Now let's see what we have. Is n is less than 0? No. N equals to 0? No. We will go in else. So the statement for the else, that was quite long, so I have written the whole statement over here. Now, how to evaluate your mystery statement? So as you can see, this is your mystery call. This mystery, I'm highlighting it with my blue marker. So mystery n divided by 10. So you are here when your n was equals to 5. Now, as you receive a mystery call, you will not solve rest of this part. What you will do is, what I tell my students is like to drop the arrow down. Like this is a mystery call, means make a method call again. So we will not solve this part first, because as you receive the call, compiler goes back with a new n, and your new n is n divided by 10. So 5 divided by 10 will be 0. You go n is less than 0? No. N equals to 0? Yes. Value return is 0. So this call went to the, when n was 0, it went to the base case. So you will give the value back to this mystery n divided by 10. This blue box which I highlighted is now holding 0. This will, now you will solve rest of the expression. What we have is 0 times 10 will be 0 plus 9 minus, now we have parentheses, so you will solve this first. N mod 5. As you can see on this statement, your n is 5. 5 mod 10 is 5. 9 minus, and now this is your final statement. 0 plus 9 minus 5. Addition and subtraction have the same precedence, so we will go left to right. 0 plus 9 will be 9. 9 minus 5 is 4. So 4 is the answer for your mystery 5. Okay, so now let's do the third one. Before jumping on to the third one, I'm directly doing second last, which is the biggest number. So let's take a look. We have n equals to 297. Now this is a bigger number, so it means we will have this mystery call again and again. What I am doing is removing this part. You already have the code. We will not go to this negative section. I just need more space to solve this, so that's why I'm just making a space. When your n is equals to 297, is your n less than 0? No. Equals to 0? No. We are going into our else part where we have our recursive call. So we are coming over here when your n. So what you have to do in this type of mystery questions, always keep track of your n. So just like this, I'm writing n equals to 297. And when my n was 297, I went into else, and this is my mystery call. Dropping the arrow down. My new n is 297 divided by 10 will be 29. So we already know that it again go over here. Your new n is 29. Is 29 less than 0? No. Equals to 0? No. Again we are in else. It means we are again in our mystery call. Drop the arrow down. And now with a new n divided by 10. N was 29. 29 divided by 10 will be 2. Right? So now your n is 2. Again you will make a mystery call. Your n is 2. Is less than 0? No. Equals to 0? No. Again you will drop the arrow down. 2 divided by 10. So what will be 2 divided by 10? So your n will be equals to 0. Now your n is 0. You go with a mystery call. N less than 0? No. Equals to 0? Yes. Return 0. So this took you to the base case. So the value returned is 0. So this 0 goes to, now one by one you have to take the arrow back. On every step you have to solve this whole expression. Let's take a look. So this mystery, you have to assume that this whole statement is copied on each and every n. So this n equals to 2, have this mystery. So 0, so the value returned is 0. Now 0 times 10 is plus 9 minus n mod 10. So you have to assume that you have this whole thing, and this was your mystery n divided by 10, which has given you the answer 0. 0 times 10 will be 0 plus 9 minus, solve the parenthesis, n mod 10. So this is your 2. 2 is your n. 2 mod 10 will be 2. 9 minus 2 will be 7. So now you will return 7 over here. So it will be 7 times 10. 70 plus 9 minus n mod 10. So your n over here is 29. 29 mod 10 will be 9. Now you will do 70 plus 9. 79. 79 minus 9 will be 70. Will be returned to this part. Now 70 times 10 will be 700 plus 9 minus, now n is 297. 297 mod 10 will be 7, and now you will go left to right. So what we will have is 700 plus 9, it will be 709 minus 7, so it will be 702 is the final answer for mystery N297. Okay, so now we will be moving on to the next question, but before that, just to remind you about the previous one, where you in the last value you have the negative number. For that question you have a second else if who is calculating the negative number. What that method is doing is just making that number positive and passing back to the method. So if you have a negative number, you will treat them the number same as the positive number, and what you will do is put a negative sign with your answer. Okay, so let's move on to the next mystery solve. This is a mystery question, so this is a little bit different to the previous one. You just need to understand how this mystery call works in every different situation. Okay, so let's take a look what we have. So you can see in front, that's the question. You can again take a picture. The second one is the question I have written on my board, and then it's a little bit different as compared to the previous one. So all we have is mystery 13. So your n is equals to 13. So what you will do is you will take the mod with 2. So n is 13. 13 mod 2 equals to 1. That's true. System.out.print n, and the output is 13 itself. You're just printing the n. If on the very first, if the mod is 1. Okay, now let's take a look what we have. I'm just moving on to number 3. Look, when n is 40, and what we are doing is n mod 2 equals to 1. No, you go in else where you have system.out.print n and comma. So I'm just writing my output with a blue marker over here. So you will print n 40 with a comma, and then you have a mystery call. Okay, so in this situation, we will not come back. Just like the previous one, we will coming back tracing our output. Why we are not coming back? Because our mystery call is at the end, and there is no expression with our mystery call. So there is no point of coming back. What this mystery call is doing is just taking you back or just running a loop. But in the previous one, you had times 10 plus 9. You have the whole equation which you left behind, right? You need to solve that part as well. That's why you were coming back after went into the base case. in this scenario, your mystery statement is at the end and there is no expression with it. So we will, once we went into the base case, we will not come back. So system.out.print, now you have mystery call n divided by 2. So 40 divided by 2 will be your new n. I'm just making an arrow over here. So your new n will be 20. Now 20 mod 2 equals to 1. No, again you go system.out.print n. So you will print 20 comma, and then again you have a new n divided by 2. So now your new n will be 20 divided by 2 will, your new n is 10. Again, is 10 mod 2 equals to 1? No, we will go in else system.out.print n 10 comma, again you have a new mystery call n divided by 2. So your new n is n divided by 2. 10 divided by 2 will be 5. Now you run again 5 mod 2 equals to 1. Yes, system.out.print n, which is 5. So this is your output, the whole line 40 comma 20 comma 10 comma 5 for mystery 40. Okay, so this is how you solve this type of mystery question. So as you have seen, we after went into the base case, we didn't come back solving for our mystery thing. So this is how our mystery number 2 works for recursion. Okay, so this is our third mystery question. So again, this is different from the first two what we have done. You will see the question in front of you. You can again take a picture or write it down somewhere so that you can keep track what I am doing on the board, because on my board it's a little messy or you may see some errors, but if you can just take a picture, I'm just following that picture. Okay, so what we have is, you have public static void mystery. So in this case, again, this is void. We are not returning anything. It means there will be some system.out.print statement inside. We are again asking for one integer value, and then we have one base case and one recursive case in this situation. So let's do a dry run of, let's trace our output. So first one is mystery 8. So your n is 8. When your n is 8, is n less than equals to 1? No. So we are going in system.out.print. Okay, so now this one is different from the first two. How? What we have is, you are printing system.out.print statement first, then you have a mystery call, and then you have one more system.out.print statement. So after printing the first system.out.print statement, just say 8. 8 mod 2 will be, so if anyone who's wondering how we are taking the mod, so what you do is 8 goes inside, 2 is outside, and 2 times 4 is 8, and this part is the mod part, the percentage, and this is the division part. Okay, so just in case if anyone is thinking what mod is I'm saying, it's the remainder of two numbers. Okay, so now let's take a look. System.out.print n mod 2. Okay, so what we have is 0 is the mod. So let me write the output. So 0 is printed because this is system.out.print. It just directly prints. After printing n mod 2, you went up over here with mystery n divided by 2. So over here now what I want you to do is, you need to keep track of your n. So mystery, at the first mystery call when you had 8, now you are going, after printing 8 mod 2, there is a mystery call 8 divided by 2. So 8 divided by 2 was 4. Your new n is now 4. So your new n is 4. And what we are doing is, again, 4 is not less than equals to 1. We will go in else system.out.print 4 mod 2. Again, 4 mod 2 will be 0. Then again you have a mystery call n divided by 2. Now your new n is 4. 4 divided by 2 will be, 2 is less than equals to 1. No. You again go in else system.out.print 2 mod 2. Okay, so now 2 mod 2 will be 0 again, and space mystery. Now 2 divided by 2 will be, now you have 1. Your n is 1 now finally. So if n is less than equals to 1, it's not less but it's equals to 1, system.out.print, you went into the base case, it means stop, and now print colon. I'm just moving on to the next line. It doesn't mean you have to move on to the next line. I don't have that much space, but we went into the base case. Now in this situation we have to come back. Why we have to come back tracing our values? Because just take a look, you missed one system.out.print statement whenever you had that mystery call. Now you will come back one by one. So this was your new n when n was 1. So this went into the base case. Number which went into the base case doesn't count for keep backtracking. So this one is gone. we will backtrack with 4. Oh, sorry, we have 2 as well. We missed 2. So 8, 4, 2, and 1 was the numbers. So 1 went to the base case. We will not write 1. We will start with 2. So after column, you will write 2, 4, and 8. Why I have written 2, 4, and 8? Because your last system.out or print statement says print n. So that's why you need to keep track of your n every time you had that mystery call. Okay, so let's do one more example. The last one, which is n equals to 46. Okay, so n is 46. Clear, it's not in the base case, not less than equals to 1. So it means we have to keep going into our else as long we don't get 1 as an n. So let me keep track of my n on this side. So my n is 46. After 46, so when you go in else, n mod 2. So 46 mod 2. So let's take a look. This is your, because you have to keep track of your n as well. So 46 and 2, 2 times 4, 3 times 6. Your mod is 0. So here I am writing the output. It's 0 for the first n mod 2. You need to keep track of your n. Now you have a new n, which is mystery n divided by 2. So 46 divided by 2 was 23. So let's remove this part. And now your new n is 23. Again, we will keep doing else part as long we don't get n as 1. Now 23 mod 2. So 23 mod 2. Mod 2 will be 1. And what we have is system mystery call n divided by 2. Your new n is 11. 11 mod 2, 10 and 1. This is your mod. Your new n is 5. Now again, let's do with 5, and what we have, we will keep doing this until and unless we have n equals to 1. So now 2 times 2 is 4. Your mod is 1. We are printing the mod. So far what we have is 0, 1, 1, 1. 1 is the mod. Your new n is, again, mystery call n divided by 2. Your new n is 5 divided by 2 will be, again, is not less than equals to 1. Okay, so we are close to reach our base case. So let's take a look. N equals to 2 now. So 2 mod 2 will be 0. So I will write 0 over here. So far what we have is 0, 1, 1, 1, 0. Now mystery call 2 divided by 2. So 2 divided by 2 will be 1. So now you have n equals to 1. So this 1 goes into your base case and print a colon. So this is a colon with the number, and as this n went into the base case, so we will not count this n as our backtracking part where we are doing system.out.print the n. Now you will print all the n one by one starting from bottom to the top. So 0, so your final output is 0, 1, 1, 1, 0, colon, 2, 5, 11, 23, 46 is the final output. That's it for this video. I think you may have get the idea of how we are tracing the recursion with 3 different scenarios. So in our next video, we will jump on to recursion programming, and that's going to be a little tricky. So I hope that you may have get good grasp of the recursive tracing, that how recursive tracing works. If you don't know how that recursion works, you won't be able to understand how recursion programming will work. Okay, so or how you will be writing the recursion code. Okay, so that's it for this video. Thank you.